Hi, my name is Jack Hall. I've been tutoring basic math at El Paso Community College now for about 30 years, a little under 29 point something. And in that time, I've discovered a few mathematical techniques that just make math itself easier, actually kind of make life itself easier. One of these techniques is called prime factorization. Now, what I mean when I say prime factorization is just breaking down numbers into their prime components, into prime numbers. That's like, say we have the number 6. Well, 6 just breaks down into 2 times 3. That's prime factorization. Taking that 6, breaking it into 2 times 3, or taking, say, 12. Well, that's just 6 times 2. Which is exactly what this says, 2 times 2 times 3. Or it also says 4 times 3. Okay, this is prime factorization. We can use this for all kinds of neat stuff. I use it for finding square roots and cube roots without a calculator. Here, let me show you what I'm talking about here. Let me clear this canvas. Okay, let's see. Now, say we need to find the square root of 625. In other words, the number that multiplied by itself gives us 625. Now, if you memorized your squares, you'd probably know it, but you'd probably have to memorize quite a few squares to get all the way up to 625. So let me just go ahead and show you the easy way here. Okay, now I'm going to bring up 3 rules that I use for prime factorization. Now let me move these over just a little bit. There we go. That's just moving right there. You know something, actually, I don't think that's going to fit on the screen after I finalize this video. So let me just go ahead and erase the 625. Let's start that over again. There we go. Now, let me bring up those rules again. Okay. Here we go. A, if it's even, divide by 2. B, if the digits add up to a multiple of 3, divide by 3. And C, if it ends with a 5, divide by 5. Okay, well, the first rule is pretty straightforward. All even numbers can be divided by 2. No odd numbers can be divided by 2. Okay, and the rule C, if it ends with a 5, divide by 5. That's pretty straightforward too. If the last digit is a 5, then you can divide by 5 like the number we have. Let me go ahead and write that number. Anyway, I'm not going to write it yet because that'll make my rules disappear real quick. Okay, that number 625 does end with a 5, so we know we can divide it by 5. Okay, now here's the tricky rule. If the digits add to a multiple of 3, divide by 3. Okay, now I'm going to go ahead and make these rules go away. They're just going to go behind. I'm going to go away. Okay, well, let's take the number 625. Get back to my pen. There we go. Let's take that number 625. Okay, now, rule A, if it's even, divide by 2. It's not even. Can't divide by 2. Rule B, if the digits add to a multiple of 3, divided by 3, well, 6 plus 2 is 8. 8 plus 5 is 13. 13 is not a multiple of 3. So we cannot divide this by 3. But that last rule, if it ends in 5, divide by 5. Let me bring those rules up again. There we are. Ends with 5, divide by 5. There we go. Let's go ahead and divide this bad boy by 5. Okay, let's see. 625. divided by 5. I know 5 goes into it because it ends with 5. Okay, 5 into 6 goes once with 1 left over. 5 into 12 goes twice with 2 left over. 5 goes into 25 5 times. There we go. No remainder, and this number ends in 5, so guess what? We're going to go ahead and hit it with a 5 again. Okay, 5 goes into 12 twice with 2 left over. 5 goes into 25 5 times. And then 5 goes into 25 5 times. And 5 goes into 5 once. Okay. So basically what we just found out is that 5 to the 4th power equals 625. But that's not what this question is asking. It's asking what's the square root? What number times itself? Okay, you take 2 of that number and you multiply them, not 4 of them. But we can use this for that because see, here's 2 5s right here. 5 times 5 is 25, and guess what? We got 5 times 5 right down here too, and that also is 25, and let's find out. 25 times 25. All right, 5 times 5 is 25, carry the 2, 2 times 5 is 10, and 2 is 12. Then we've got 5 times 2 is 10, carry the 1. 2 times 2 is 4, plus 1 is 5. That's a 5, that's a 2, 1 and 5 is 6, see? 625. So the square root of 625 is 25. Okay, now I also said cube roots, didn't I? So let's see if we can find, I'm going to use one that I already know. Cube root of 216. Now I recommend to all students, all basic math students, learn your squares, learn your cubes. Learn your squares up to at least 13. Learn your cubes up to, well, 10, but tell you the truth, you can usually get away with learning your cubes just up to 6. And you can use factoring, always, to find cube roots. Let me show you what I'm talking about here. Okay, when we say cube root, we mean the number that multiplied by itself 3 times. In other words, 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. Okay, so when you see 3 to the 3rd power, don't go 3 times 3 is 9 and leave it at that. That's not what it means. What it means is 3 times itself. 3 3's multiplied together. That's probably the easiest way to look at it. So 3 to the 3rd power is 27, not 9. Anyway, it could take us a while to get up to 216. Let me show you the easy way. Okay, we're going to take that 216 and we're going to follow the rules. Okay, now rule A, if it's even, divide by 2. Guess what? It's even. I'm going to divide by 2, but check this out. 2 plus 1 is 3, and 3 plus 6 is 9. See, I could divide this by 9, but I'm going to go ahead and do it by 2 because I like keeping all my numbers grouped together, all the like numbers. Okay, 2 into 2 goes once. 2 does not go into 1. We need to put a 0 there. Carry that 1 over to the 6, make it 16. 2 into 16 is 8. All right, it's still even, but you see, we can still see that 3 in there. 1 plus 8 is 9, and 9 is multiple of 3. Therefore, we could divide this number by 3. But it's even. I'm going to hit it with a 2. 2 into 10 is 5. 2 into 8 is 4. Okay, and you see we still have that 3. 5 plus 4 is 9. Okay, well, 54 is an even number though. I'm going to go ahead and hit it with a 2. You know, keep my numbers grouped together. I don't know. Maybe it's OCD or something like that, but I just like keeping numbers grouped together. Okay, 2 into 5 goes twice with 1 left over. 2 into 14 is 7. Okay, now this number is no longer even. I can no longer divide it by 2, but guess what? That 3 is still there. 7 plus 2 is 9. So 3 goes into 27 9 times. Well, we know 9 is just 3 times 3, so 3 goes into 9 3 times. 3 into 3 goes once. Okay, so 2 times 2 times 2 times 3 times 3 times 3 is 216, which is good, okay? 2 to the third power times 3 to the third power is 216. It's a good thing to know, but it doesn't answer our question, does it? We need to know what number times itself 3 times gives us 216. Well, if we take these numbers right here, 3 times 2, we get a 6. If we take these numbers, guess what? We get another 6. And then let's go ahead and take these last numbers, 3 and 2, just like the other ones. We get another 6. This tells me 6 times 6 times 6 is 216. In other words, 6 is the cube root of 216. You see, that's one of my favorite uses of prime factorization, is finding roots without a calculator. Because calculator's not always going to be there. Some teachers won't let you use it, especially in this level of a math class, the basic math classes. And I think it's fun. I don't know, call me crazy. A lot of people have. But I'm a crazy man who has a whole lot of fun at work. Okay, I'm going to go ahead and erase this page. And let's go ahead and see probably one of the most useful applications of prime factorization. Okay, let me go ahead and bring up those rules again. Wait a minute. There we go. Okay, rules of prime factorization right there. And keep these rules in your mind, okay? If it's even, divide by 2, especially letter B, if the digits add to a multiple of 3, divide by 3, because that'll help you in places other than prime factorization. But anyway, I was actually just seeing how much space it took up, because I'm going to go ahead and add subtractions. Now, before you can add or subtract fractions, you got to have the same thing on the bottom. You got to have a common denominator. Okay. These are 3 different denominators. I have an 18, a 24, and a 36. Now, I could use my super brain and just come up with a number that can be divided evenly by 18, 24, and 36 and change all of those into that number. But I'm probably a little lazy to do that. I'd rather do it an easy way. Actually, I'd rather do it in a way that's easier to understand, because to me, math is not really hard. It's just kind of tedious. Okay. All we really need to do here is make those bottoms look alike. Make those denominators look alike. So let's see. What I'm going to do is I'm going to use our good friend, our new tool, prime factorization. Now, 1 doesn't break down any. It doesn't need to, because it's 1. But 18 divided by 2 is 9. 9 divided by 3 is 3. And 3 divided by 3 is 1. Look at that. Okay, bring down the sign. Plus 1 over. Now, 24 divided by 2 is 12. 12 divided by 2 is 6. 6 divided by 2 is 3. And 3 divided by 3 is 1. Can't divide 3 by 2, not evenly. I'll give you 1 1/2, and you see, you got that half. You got a fraction. Don't want to deal with those things. All right, let's go for 1 over 36. Okay, 36 divided by 2 is 18, which divided by 2 is 9, which divided by 3 is 3, and 3 divided by 3 is 1. Okay, let's see. Now, all we need to do here is make the bottoms look alike, but anything we do to one of these fractions to make the bottom look like the bottom of another fraction, we have to do to the top. And the reason for that is that we end up multiplying by 1. Okay, this is what I'm talking about. Okay, you notice I've only got 1, 2 over on this first fraction. but I've got 3 of them on the other one. So if I want the first fraction to look like the second fraction, I'm going to need 2 more 2's. Okay, there's 2 2's down there. Let's go ahead and put 2 2's up here too, because then what I'm multiplying this by is 4 over 4, which is 1. And anything multiplied by 1 is whatever it was before. Let me move this third fraction here. So I've got room to do my whole common denominator thing. Okay, let's see. Put the plus over here. And then it's going to be 1 over 2 times 2 times 3 times 3. Or 4 times 9, or actually, let's look at it as 12 times 3. Anyway, okay, got that done. Now, okay, notice I'm just multiplying this first fraction by the number 1, okay, because 4 over 4 is 1. Any number divided by itself is 1. It's not going to look the same as it does right now. It's not going to look like 1/18, but believe me, that's exactly what it's going to mean after I do this multiplication. Okay, so we got 3 2's and 2 3's on the first fraction. Let's look at the second. We got 3 2's, good, but we've only got 1 3. So for this second fraction to look like the first fraction, I'm going to have to give it a 3 on the bottom. And if I do a 3 on the bottom, I'm going to have to do a 3 on the top. Again, I'm only multiplying by 1 because 3 divided by 3 is 1. And a fraction bar is just a division sign. That's all it is. Okay. 3 2's, 2 3's, second fraction, 3 2's, 2 3's, third fraction. Ooh, we only got 2 2's. So guess what? I need 2 over 2. All right, which again is just 1. All right, now, if you take a look and see, you'll see that we have 3 2's, 2 3's, 3 2's, 2 3's, 3 2's, 2 3's. They all have the same thing on the bottom. Okay, so now we're ready for this. The first fraction, 2 times 2 times 1 is 4. Plus that second fraction, 1 times 3 is 3. Plus 2 times 1 is 2 on the third fraction. Over the mystery number, the smallest possible number that can be divided by 18 and 24 and 36 is 2 times 2 is 4 times 2 is 8 times 3 is 24 times 3 is 72. Which, as you can see, is divisible by 3 because 7 plus 2 is 9. But you knew that, huh? Okay, now 4 plus 3 is 7 plus 2 is 9. Over 72, which would be the end of it, except that 9, well, that's actually what, 3 times 3, isn't it? Now let's take a look at 72, which is 2 times 2 times 2 times 3 times 3. We know that from the previous step in this list of math steps here. Okay. Now, notice all these numbers are multiplied together. Okay. And that division bar goes right through the middle there. That's a division sign. In other words, what we have here is 3 divided by 3 is 1. And 3 divided by 3 is 1. Now on top we've got 1 times 1 is 1. On the bottom we've got 2 times 2 is 4 times 2 is 8 times 1 is still 8 times another 1 is still 8. So all this equals 1/8. See, it's like magic. Now let me bring up our good rules here again. Rules A, B, and C. If it's even, divide by 2. If the digits add to a multiple of 3, divide by 3. If it ends with 5, divide by 5. Okay. Well, I hope you had as much fun listening to this as I did making it. Let me end this right now, and I'm going to go ahead and make a bunch more about different things. All of it meant to make your math easier. All right, you take care. We'll see you sometime soon.